So next week, your assignment is due on Friday, and I expect you to present your proposal. So it's going to include your introduction, which has the background to your research question. You're going to mention the research question in the introduction, and then you're going to elaborate with your literature review, which positions your research questions in past literature. And then you're going to present your data and methodology. That's what I want to see on next Friday. If you don't have that, you're going to do poorly on your proposal. If your proposal isn't adequate, I'm going to give you data and a research question, but I don't think you should wait for that because then you're going to have to start over again with your literature review. So make sure this week you tie it up what you're doing. If you need to meet with me to discuss it, I I can meet with you tomorrow or after class. I know tomorrow's a holiday, but I can meet with you tomorrow. We can make use of that time. And also we can meet on Friday after class. All right. So
So,
um
Professor,
hmm, tell me.
so for tomorrow, we could just enter at the same time to the meeting if we have questions,
We
or
can
do we have to
schedule
send an email?
well we could do that. That would be we can meet at the time of the class, but if you need a different time, let me know and I can meet with you. But yeah, I can enter. I can enter at 10 o'clock.
Okay,
Yeah,
yeah.
that's a good idea. All right, so I asked a question. How's everyone doing with assignment 3? Put your answer in the chat, please. I only have 2 answers. Okay, Noelia. Okay, so you didn't start. All right, but is what I'm doing helpful, or should I leave it for you to do it yourself? Am I helping you with the information I'm giving you? There's some scratch here. I don't know what that is.
Yeah, there is.
What is it? I can't even see it.
It's okay. Don't laugh it. That's it. Just to rush.
It's weird. Sorry. So let me know if I'm helping you or not helping you, and what can help you, how I can help you. Put it in the chat. Be honest. We have no time. Time is precious. We want to use our time the best we can. Not helping? No comments? Are you writing? You thinking? Okay, it's helpful. Okay. So we're going to continue with my demonstration, and then I have a number of sets of notes that I want to put up as reference for you. I think they're very good, but I'm not going to go line by line on the notes. I'm going to expect you to go through the notes, and then you ask me, okay, if you have. So there's just like reference material that may help you understand. Okay. All right. So should we get started? We're going to continue with what we're doing, just so you completely understand. I want to backtrack a little bit too. I want to say something about the terminology, right? I feel like I kind of glossed over that. And let me know if there's any issues with my language that I use. Sorry, my poor voice. What in the world did I get? I've been sick for a while now, and I get better and then I get sick again. All right, so let me share. Let's go back to model 1. Oh, let's talk about model 0. Remember, 0 was just a simple linear regression. Can you guys see? That was just a simple linear regression with odometer predicting price. And we had our results here looking at the F-stat with the null hypothesis. Coefficient estimates are all 0 versus the alternative that I didn't even write it down. I can write it down. So the alternative hypothesis is that at least 1 is not 0. At least one estimate coefficient is not 0. It could be all of them. I mean, there's only one in this case. But that is the that's the alternative hypothesis. It's moving things along. Oops. It's completely gone. Get it back. All right, then we progressed here and I talked about the p-value of the test, which it gives you the probability of seeing the result if H naught is true. And the probability of seeing the result you got for the coefficient is so small. And then we ask, what is small though? Small is less than 5% p-value. And if you have a small chance of seeing something, but you saw it, we go to the assumption and we reject the assumption. It's the assumption that's wrong, not our mathematics, not our sample, not our calculation. It is the assumption. So the assumption is wrong, and we say we reject H naught. And then we can also say things like the odometer. Well, we can say more generic. The test is significant, okay? And we can say the test is significant at the 5% level, something like that. Or well, significance. Okay, so the test is significant. That's the terminology we use. So the test is significant. We see the same result here when we have just one variable. Our p-value is going to be the same as the f-test. Okay, so that's how we use the terminology. In the second model, we added a second variable. We wanted to relate we wanted to introduce age because, okay, use of the car has an effect on the price, but there's also something to be said about age because age, like the older the car, so we saw when we plotted age and price that the age of the car, um, the the older the car for the first few years made the price go down, but then much older cars kept in good condition, obviously to be alive or surviving so many years, they had higher prices. So we introduced that as a second variable, and we did the same analysis pretty much. We just included that second column, and then we got similar results, but this was a better model according to the R square or the adjusted R square we could even look at. And then we can interpret the, oh, sorry. What is this? R square. Yeah, 17. Did I do this? Now I'm looking back. Did I interpret this? R square, linear regression correlation. Oh, I did this. I interpret this R square as the correlation coefficient, which is not correct. Actually, I just noticed that. Okay, so linear regression, let's go back and fix this. So this is R square, not R. What would R be if R square is 0.07? That's so funny. It's like I never read these. I see I was so out of it. Okay, so if R square is 0.0775, what is R? So let me fix this. Unbelievable. Make mistakes. So you have to take the square root of this to get the R. What's the square root of 0.08? You guys never caught me. I'm sorry. I felt like I had to give class and I knew I was making a lot of mistakes yesterday. 0.077531 square root. Now I got to do this. I did it. You take the square root of 0.077531309. 31309 square root is 27. Okay, just 27. Okay, so I guess that's giving me, it's so weird. By square root, 0.278. All right, so this is the R squared. So you would have to take the square root to get the R. Now I have to fix this. Which gives you 278. Now I'm really confused. So what is this? 27. Okay, so this is the R squared, but the square root of that is going to give me the R. So R is the square root of R squared, which is 0.278, which is, let me put this as, trying to put everything here. So it's close to zero, okay? So we don't say it's no because it's not zero, but it's
Professor, that's the multiple R that you have above it.
I know, but I'm trying to correct the fact that this is R square and we want R. I don't even know multiple R. I'm sorry. That's a weird terminology for me. If they think that that's called correlation, let me check here. They changed some terminology that I already never noticed. Coefficient. Oh, I see what it is. So the multiple R means the absolute value of the correlation coefficient. It's not the correlation coefficient. So actually, none of this is giving you the direction. How do we know that this is actually negative? I'm going to put a negative here. Do you remember in the first plot that I did, what was the shape of the relationship between odometer and price? Was it going up or down? What was the trend?
Was negative, the relationship.
Yeah. So there's no negative. It's not showing you the negative here. The way you're going to get the negative is in the coefficient. That's also how you're going to know. Okay, that's going to show you. All right. So recapping, they give you the R square. If you want the R, which is meaningful for the simple linear regression, you have to take the square root, and that's negative 0.27, which is close to zero, indicating no correlation or no linear correlation. The term multiple R is the absolute value of the correlation coefficient. So it's the same number, but it's like positive version of it. And I'm glad I did this review. And in the end, what we're supposed to look at is the adjusted R square that adjusts for having more and more variables added to the model, because the R square will always go up the more values you have, but you want a model that fits better, not just a model that shows R square going up because you add more and more variables, right? You want just to use the variables that are necessary. You want what we say is a parsimonious model, just the necessary variables, sufficient and necessary. So anyway, that's the one we're supposed to use here. All right, so, and we're going to monitor, the main thing about this is we're going to monitor the adjusted R square and see it going up and say, okay, we're improving the model. That's the idea there. Okay, so we're going to go to one. So anyway, did you guys all fix that or copy that? I'm going to have to adjust. What I'll do is I'm going to put that in on the platform, I guess. I'll put my results. All right, so I kind of glossed over that, the other class. Nothing else changes. So then we're going to go to the first model. The first model, I add in the two variables now. So I put two variables in there. We see the adjusted R square goes up from what it was before, 6.068. And I had I had a statement here in model 0, like, interpreting the R square. And the R square means that, I'm going to put it here. That you interpret it as a percentage. So 7.75% of the variation in price is explained by odometer, which is very small, right? It's very small. It's a lot of scatter around that line, and that line doesn't even fit the shape of the relationship. So we improve the model, deciding that there's other variables that are missing, and we're going to include age. So we include age, and this goes up. I'm going to put a box around it. Okay, so this has gone up. It's improved. The model is improved. Or has an improved fit. According to the adjusted R square. Then we went through, oops, and we again discussed significance, and that we interpreted the results. Model 2, we further improved the R square. I don't know why I have that there. This -1 to 1 is for R, not for R square. I have that here. No. I put this here. This is for the R, to look at R. I think I just wrote it there, not to confuse you. I'm just fixing this for posting. And oh, geez. All right, so that's not, again, this is the overall R that has an absolute value on it. This is the R square, and this is the adjusted R square. So we would interpret this as, how would we interpret this? Who's going to tell me? Put it in the chat. How do we interpret this result? How do you interpret the adjusted R squared for model 2? Put it in the chat.
Can you say again?
Interpret the adjusted R square. Put your interpretation in the chat. You guys, you need to be, I know this class is intense, but you have to be equally intense and involved because you're not going to follow this stuff.
Professor, you're still asking for the adjusted R-square interpretation?
Yeah.
Okay, so I believe it would be 57% of the variation in price is explained by the three variables.
I asked you to put it in the chat.
Ah, okay, sorry.
You guys are not, you guys aren't, only Raul is like responding and Anthony. You guys need to be much more involved. Okay, the main thing about the adjusted R square is we use it in sequence, okay? The fact that we start with a model with no, with one variable, one independent variable. And here we interpret that 6%, 6.8% of the variation in, I just did R squared. So if we use the R squared, means that 7.75% of the variation price is explained by odometer. But then I tell you, we're going to go to the adjusted R squared and look at that, which adjusts for each variable that you add. And we're going to compare as we go along and improve the model, we compare it. So it's like a relative measure of improving your fit. Okay, that's how we're going to use it. And the videos, it'll explain the calculation. And you don't have to calculate it, but you need to interpret it. I'm asking you for minimal things here. All right. So let's go to the next model, which I left you with. I'm surprised none of you looked at it. So we created a variable called age square, and we're going to look at the next model. Okay, before I do that, I want to talk about what we're doing in because we're jumping from what's called a linear model to a nonlinear model, but we're going to make it linear. Okay, so what's a linear model? What's a nonlinear model? So one example, and this are just parts of the notes I'm gonna share with you. Um, let me. All right, so um all right, so here's a from economics. We have, oh, I lost it. Here is the demand function for a good. Quantity demanded. When you learn economics, this is the model that you learn. All right. Now, if you've seen it or not seen, how many people have seen this model written like this for a demand function? You've taken economics. This is the microeconomics. And you learn about the influences of different variables on demand. What are some of the variables that influence demand for a good? Let's see if you guys can identify them here. It kind of gives you a hint because there's letters. Let's see, put it in the chat or tell me, what are the factors that influence demand for a function? I mean, demand for a good. I'm still out of it. Nope. Or I'll put elasticity. No. What influences demand for a function? What are the factors? Okay, so the P here stands for price. Very good, Robert. What else determines the demand for a good? So this is a demand function for an economy. Okay, so price of the good influences demand, but there's other factors. It's not just the price. What else? There's some hints there. Seriously, guys. Okay, this is for society. So the more people there are, the more demand. That's what the N is. That's the number of people. Okay, what about some of the other variables? What other factors influence demand for a good? Think about an iPhone. Think about a, I don't know. You have, I'm trying to think of what you guys buy. Concert tickets, movie tickets, cars. Hmm. The quantity demanded of a good is dependent on price. The M stands for income of people. If income goes up, people are more likely to buy a good. The price of related goods. So if we're talking about food, let's say, and the price of, um, okay, in Puerto Rico, people eat lots of rice and beans. If the price of rice goes up, that might affect the quantity demanded of beans because those go together. So this is the price of related goods. T is for taste or preference. So that could be influenced by marketing. Anthony mentioned. I think this has to do with the expected price. So if the price is going to go up in the future, maybe people will buy more of it today to avoid having, so because there's inflation, the price in the future is expected to go up, they're going to buy more today. So these are some factors that influence quantity demanded. I don't know what you guys learned in microeconomics, but you should have learned that. Did you guys learn something like this in microeconomics? This is what it looks like. Maybe they never spelt it out like this, but these are the factors that influence quantity demanded. And what ends up happening is you just model this quantity and price. So we just look at quantity and price relationship, but we see all the other variables as factors that move the demand curve if they end up changing. So this is the sort of thing that you see, all this discussion. What do you expect? So those numbers in front, I thought this was going to be helpful. Now I'm not sure. These are the coefficients. So this is the coefficient that you would get in a regression if you found all this data. The coefficient B that's there would be, the resultant of your regression. The coefficient C would be the coefficient in front of income. The coefficient D in front of the price of related goods. E in front of preference or tastes. And F, etc. Okay. So what do you expect those to be? So this is what you guys have to do with your modeling exercise. You're going to find data, you're going to have a model, and then you're going to run a regression to check the relationship. So initially you have to outline what you expect. If you were running a demand function and you happen to have all the data and you're able to run this, what do you expect the coefficient B to be? Positive or negative? Let's not talk about the magnitude or how big the number is, but is it positive, expected to be positive or negative? What's the relationship between price and quantity demanded? As price goes up, negative. You guys got it. So that's what you have to think. Okay. All right. What about income? As the income goes up for people, so what do you expect? So now you start thinking, aha, wait a second, what about all these other variables? So even when I said that, let's go back to price. If the price goes up, you guys told me the quantity demanded goes down, but we have to talk about those other variables here. We assume the other variables don't change, all right? Because if I ask you to tell me the sign and all those other variables can change as well, it's going to be hard to predict the sign, right? Because there's a relationship between those variables. So that's why we're doing the hold all other variables constant kind of terminology that I use, the ceteris paribus, because it's hard to make an interpretation or prediction or understand what that coefficient will be. That's what the regression allows us to do. It gives us the marginal effect. So this will be negative in a regression results. It should be negative according to the theory, while all these don't change, just price changes. So what if income changes, but nothing else changes? So the income of people have more money. What's the relationship between quantity demanded if people have more money? So you should be hesitating, thinking, well, it depends. It depends what kind of good it is. If it's something people want, when they have more money they can afford, then that should go up, right? More money, I'm going to buy more. But what if you have more money and you don't have to buy that good anymore because you have more money, you can move away and buy something better? Then that would be negative. So it depends on what quantity demanded good we're talking about. What good are we talking about? So this is the discussion of normal goods and inferior goods. If it's a normal good, we expect the sign to be what? So if it's a normal good, we expect C to be what? As income goes up, if it's a normal good, it should be put it in the chat. Very good, Anthony. Everybody else. So a normal good, people want more of it when they have more money. That's a normal good. All right.
Professor,
Yes.
in that case, that's why the variable with the coefficient E is important because it tells you how interested the person is in the product, right?
E here, this one?
Yeah. I thought that's the one that
We're not there
measures
yet. We're
interest.
not there yet. Let's
Oh,
focus
okay.
on C. We're gonna go that's why we have to put all those other ones in. This I really like this because everyone can connect to this, and even if you didn't learn this before, you guys are almost done with finance program. You should know this. So I'm glad I'm taking a moment to do this. And we can reason through this, and a lot of this terminology you should have heard before, and hopefully this is a good example. And anyway, so C for a normal good, if the demand that we're looking for is for a good that's normal, C should go up. What if it's an inferior good? That's another, that's a different kind of good. That's a good for which if your income goes up, you want less of it. Like, because you're going to buy something else because you have more money. So you're going to buy less. A common example is macaroni and cheese. When you're a student, you eat macaroni and cheese, but when you start working, you can buy other things. You're going to eat other things. You might purchase steaks, right? You might purchase, so you're going to move away from macaroni and cheese for your protein. And so this would be what if it's an inferior good, positive or negative? When you have more income, put it in the chat. Negative. Okay, so you got the hang of it. So this is the sort of thinking, that's what I want you to focus on when you're working on your proposal. You're going to try and identify what model you're going to use and what those coefficients should be, positive or negative. That's the main thing. All right, what about this one? So let's see. Let's see if I got this right. PR. So okay, here it shows you, right? So R stands for related good. So if the related good is a substitute for your good and the price of your good goes up, people will substitute and buy more of the related good. So the sign will be positive. If it's like I was saying, habichuela and arroz and habichuela, if the price of rice goes up, people are going to have less rice, but they're also going to have less beans. Those are complement goods. Okay. So that's going to influence, and you could have a variety of related goods in your model too, if you're predicting quantity demanded. All right. T is for, let me verify. I don't think I wrote it anywhere. Sorry. Okay, so T is for preference. If preference goes up, then demand for the good goes up. So the coefficient E should be positive. Okay, and marketing can influence preference for sure. If the expected price goes up, so the future price goes up, or the expected future price. So what you expect in the future, that price goes up. People will buy it now. So the quantity demanded will go up now. And if there's more people, everything else constant, right? Every time I say this, we imagine that nothing else changes. It's in marginal effect. We isolate and we say, well, if there's more people, then the quantity demanded will go up. All right, so those are the effects here. I'll put this on the, you guys can read through it. I think it's easy for you to read. So this is the additive model. It is a linear model. Now, it's not just a simple line, you see, in 2 dimensions. How many dimensions is this relationship? How many dimensions does this relationship have? So it's 2 dimensions here, 3, 4, 5, 6, 7. Okay, it's 2, 3, 4, 5, 6, 7. So it's multidimensional, 7 dimensions. You can't see it. You can't imagine it like Raul says. Okay, but we when we draw when I made my um sorry, when I plot the variables, I always plot my y variable or my dependent with each independent variable just to see the relationship between the two of them. Okay, I need to see that. So we refer to these b's as coefficients. We also refer to them as slope parameters, right? They're like slopes in different dimensions. And you can also call them, because we hold all the other variables constant, they represent the average holding all the other variables constant. So those are the different ways of referring to those coefficients. Those are also known as the marginal effects. So there's like 4 different ways that people refer to it. And let me show you. So this is just an example here if you guys want to look at it a little bit more. So what we do, you imagine this relationship. This is the demand curve, and we just use price on the vertical axis and demand on the horizontal axis. Not to confuse you more, but this is flipped, right? I put price here and quantity demanded here. It's just a convention where this is actually the y for the function that I showed you. But anyway, it works out. And what we do is we imagine shifts in this line, the demand curve. It's not even a curve. That's another that's another confusion. It's not a curve. It's just a line. It's a line based on the fact that they gave you data in a way that falls on a line, okay? But in reality, you'll see a scatter, okay? You'll just see a scatter. And you'll make a prediction line. And a shift in that line is a result of changes in the other variables. So what happens if income increases? What happens to that line? Do you guys know? If income increases, so we just talked about what is the impact of income. Let's say that good is a normal good and income increases. What happens to that line? Anybody else going to try? You guys should have learned this, but if you didn't, you're going to get it now. So what did we say? What happens with a normal good? Valeria, what happens when people have more money? What happens to the quantity demanded of a normal good? Who else is here? You guys are not answering my questions. Monique, what happens to the quantity demanded of a normal good when people have more money? The line shifts right. That's what Raul said. Not decrease, it increased. Anthony said it decreased too. Yeah, the demand is so it's going to shift over to the right, okay? Where's my curve? Here. So if there's an increase in income, demand shifts right. If there's a decrease in income, demand shifts left. So what ends up happening? So this is like what I'm trying to show you is how we can visualize one by one what those variables are doing. Okay, obviously there's a lot of things happening at the same time, but we try and isolate to understand those relationships. Okay, so back to the curve here. I know curve. Back to the equation. So here's the equation. The most important thing is that you guys realize that we're doing the same thing, okay? We're modeling the relationship with multiple variables, and we're going to look at the fit, how it fits to the data, and we're going to look at the interpretation of each of these and see if they make sense. That's the other part. You don't just take for granted, this is positive, this is negative. Does it fit the theory? Does it fit what I expect? Okay, so that's my example. The other thing I'm going to put in to the onto the platform is this is a review of regression. Just I think this is a good one. So here is the simple regression. This is the theory behind what we're doing. This is what we believe is the actual model. Okay? That this is a simple regression that we believe there's a relationship between X and Y, that it's linear, but because there's a scatter, it doesn't fit exactly on the line. There's an error term, like off of the line. So we estimate the parameters A and B, okay? And we also estimate the errors. So what we do, remember I told you about the types of data, right? So there's cross-sectional data, there's time series data. Time series data is a data set in which the data for the dependent and explanatory variables are collected over time for a single firm. Cross-sectional is a data set in which the data for the dependent and explanatory variables are collected from many different firms or industries at a given point in time. And a panel data set, otherwise known as longitudinal, mixes the two. It has snapshots, it follows firms, or it follows variables over time. Okay. And this is the model we fit. Notice that I put the y hat. I always talk about y hat as the prediction of the line, but notice that these are also predictions, right? They're just predictions. They're not necessarily the actual what we believe are the intercept and the slope term, they're just estimates of them. This is how they're calculated. This should look familiar to you. This is for the simple linear regression. And I have some talking here. This looks familiar to you. The most important thing, and that's what you're going to learn watching the videos, is about the diagnostic test. There's a theory behind linear regression. We have to test that the assumptions of the model are met. Okay, and these are those assumptions that you need to learn. One that I mentioned to you is that the error term, so the errors estimated by the residuals, should be normally distributed. They should be random around 0. We were looking at that last time. Okay, so I'm going to put that up. This is kind of reviewing what we already discussed, but emphasizing the point that there's a theory behind linear regression. So this is all about doing simple regression. But getting into multiple regression is where I'm going, okay, with you. And so here we have what we're going to do next. This is the model we're going to do next. You guys agree? So this is what we believe the relationship is. Actually, there's another term on top of it because we're going to use h squared, and we're going to have odometer. And then we know it's all scattered around, so we're going to have the E term, and we're going to test that. What do we expect the coefficient of x squared to be with the model that we just did? What did we see about h squared? Let's go back and look at the curve. So this, again, oh yeah, we have odometer 1 over odometer. So we have to anticipate what do we expect to see so that we can, even though it's fitting, is it fit what we imagine? Is it meaningful? That's what we have to evaluate as well. And that's what you're going to have to evaluate with your regressions. Let me get out of here. So I'm going to share those documents. What I really want you to do is watch those videos. The documents are for reference. So you have things, that you can pour through. I don't want you combing the internet and wasting time, as you can waste a lot of time. The best thing to do with AI or the internet is when you have an actual question that you almost know the answer, that's when you can ask it and you can interpret it easily. But trying to learn off the internet, I want to avoid that. I want to guide you as much as I can. That's why I'm here. All right, so if we go back to now we're going to do model 3 we talked about. We set it up last class, and here they are. These are the columns that I'm going to analyze. You guys ready? Maybe we want to do some plots first. I can plot. Let me erase this. It's okay. I'll just separate these for now. I can plot just to look at the scatter plot of price and age to remind you. What do we do? Insert chart, XY. Oh, I have to do it the other way around. I always remember. When I do this, I have to put them in alphabetical order, but not when I do the multiple regression. Let me move this over again. So you do the analysis in pairs. All right, let's try that. Insert chart. XY. All right, so we have price, which we're trying to predict on the Y, and we have our independent variable on the X. What is the shape there? If you were to smooth out the shape, what do you guys see? It's a parabola going up. Well, so what sign do we expect the x squared term to have? What's the graph of a parabola? What is it supposed to have? The positive happy face, right? The positive. So that this shape is a happy face smile. It should be a positive on the coefficient. Okay. Well, let's see if how odometer's doing. Let's check that one. Let's check that. Oh, that didn't work. I gotta do paste, edit, paste, special values. All right, so I want to plot this. Let's look at that. Insert. So I'm going to do insert chart XY. That looks weird. Very strange. Well, anyway, that's not going to resolve much, is it? But let's do it as an attempt to linearize odometer, because that was curvy too, right? Let's see what that does. Okay, so let's highlight, and we're going to tools, data analysis, regression. Okay, so this is working even if it's a nonlinear model. I make it linear by creating the squared term. Let's make sure it includes everything. So y goes up to e, sorry, x goes up to from b to e on mine, and then the, oh wait, y goes, what am I doing? The y is from b to b, sorry. The x goes from c to e. Oh yeah, it worked. It worked this time. I didn't have to do anything. C to E. All right, and this is going to be model 3. That's going to open a new tab. And I want all my plots. Here goes. Okay, let's make this bigger. Oh, I know. Okay, so what do we get? Okay, did the R square improve? Adjusted R square. Let's go back to model 2. What happened? Oh, did I do this already in model 2? Sorry, I did it already yesterday. Okay, no, we don't need model 3. Sorry about that. We did it yesterday as model 2, so I already have it. So we'll go back, we'll call the next one model 3. We're going to compare this to model 1. Oh, wow. So we did much better. Our adjusted R squared went to 572. So this is an improved fit. We valued that this is very zero, very, and so it means that we reject the null hypothesis, and at least one of the coefficients is non-zero, so it's significant. It's not zero, it means something. Okay, so now let's do an interpretation. So how do we go about interpreting this? Let's look at the signs first. What did we say that we expected age? So we have to put both the variable for age and age squared in there, but it's in the parabola formula, age square is the one that needs the sign tells us if it's concave or convex, or if it's, happy face or frown. So it's a happy face, you see? So that makes sense. What about these other variables? How do you interpret those? I really want you to watch the videos because they explain the interpretation. Does anybody know? Okay, I'm gonna leave that one. I'm gonna leave that one for you guys. Okay, so you guys are gonna work on that. It's explained. The videos basically do this, but they don't present um they don't present everything as I do, but it's mostly there. Okay, so I want you to get this interpretation from the video. All right. Let's do one more before we go. Let's do model 3. I'm going to fix this one. It's not supposed to be model 3. We're going to clear. I'm going to clear everything. Edit, clear, all. All right. All right, so let's do the next one. What's the third model we're going to do? Is on the list. I gave you a whole list. Model 3 is to log odometer 1 over the inverse, which was an attempt to transform it. So let me look at, okay, we have a couple of minutes. This is also nonlinear, but we make it linear by creating a new variable called log of odometer as opposed to 1 over odometer. What's that going to do? Let's make a log of odometer. Log of odometer variable. So if we take ln of odometer and we repeat it all the way down, and I need to erase some of these. What will that look like if I'm, let's just do an XY scatter plot of that. So X would be log of odometer. I did it wrong again. So insert chart. No, sorry. Insert. No. Paste special values. That's my X, and my Y is price again. And I'm going to plot them. Insert chart. X, Y. Let's see if this is any better. Interesting. All right. What kind of shape do you guys see here? Do you see a trend? Inverted U. Inverted U? I don't see inverted U, but what do you see that? Okay, there's a big scatter, and then as lawn odometer goes higher, the data seems to converge, but it kind of looks like a negative trend, no? Negative linear? It's kind of scattered, negative linear. Anyway, it's better than what we were looking at with the 1 over. Okay. So, okay, we're over our time, but what I want to show you is the different kinds of transformations and why you do them. And I can post that also into the platform. Let me show you before we go. Okay. So if you have a relationship between two variables, here is an example, and it's like curving up. If you log the y variable, it will straighten that line. Okay? So, if you have x and y in a relationship, this is more discrete. So this is like a continuous looking kind of relationship. This is more discrete. And you see, as x gets bigger, these get more spread out. To stabilize that, to put them more on a scatter along a line, you can use a log, okay, or natural log. And see, it brings them closer together on a line trend. All right, so that's what log can do in a relationship. If you reverse it, like I have it log y, you can do it for the y, you can do it for the x. It can transform that picture. Okay, so I can put these pictures up and this data. I don't know why I repeated here. Oh, okay. This is if you square a variable. So we had so if you have like a curve relationship, you want to straighten that relationship to get that linear trend, you can square that variable to flatten it out. Similarly, if these things are tightening, you see that as x goes higher, they're narrowing. You can even that out by introducing a squared variable. So this is how you can use transformations to create that more of a linear trend between the variables. Okay. And then I have also a discussion here about elasticity, or I will mention that, and what we expect to see and how we interpret the coefficients in a model like this. Okay, so I'm going to share those documents on the platform. I'm going to let you go because it's 11 past 11:20. You guys keep in touch with me, okay? You're going to have a break tomorrow. If you want to talk about your research question, remember, you need not just a research question, you have to have your model and your data identified to be able to pursue your research project. Okay? And if you need to talk to me, you can make appointments tomorrow. I will show up in the morning to meet with you just like we do every other day that I'm available. We're going to meet and I'll answer any of your questions about your projects. Okay, so I know it's a holiday, so you don't have to be there, but if you want to use the opportunity, I'll be available. Okay, so good luck with the videos, good luck with everything. Have a good day tomorrow. We'll see you on Friday. Ciao for now.